Hello everyone, welcome back to another video for the series. I'm Inoq, and today I brought a geometry problem from JMO, and it's number 5, so I expected it to be somewhat hard, but I didn't know that it was like this hard. So I realized that this problem is not actually that hard to solve, but it's really hard to see, like how, yeah. So let's just draw our diagram first. Let's let H be the orthocenter of acute triangle ABC. Acute triangle, so a like this. Oh no. A B C. Let F be the foot of altitude from C to AB. So like that's not an altitude. That's not an altitude either. I don't know why, but it's so hard to draw. I think I found it. What? It's right angle. And sorry. And let P be the so we actually do need to draw orthocenter. So this point is H, and P is the reflection of H over BC. Suppose the circumcircle of triangle AFP I don't like it. I really don't like it, but I'll just... Why? Huh? AFP. Circumcircle. Okay. How do you draw a circumcircle here? Usually, it's quite proportional to like. Oh, this is a circle. Like this, maybe. Not. No. How do we draw it? Oh wait, I think I'm starting to see the shape. Nice. Like this? Like this, I think. Nice. Let me just enlarge the whole diagram. To further. Like this. Maybe. And we have great diagram right here. Yay. Oh, one last time. Nice. So we have it. I'm quite satisfied with this drawing right here. I'm just gonna go with it. And intersects line BC. Line BC is this one. line BC like this intersects at 2 points. So this point this point should be x and that should be y. So this is y, this is x. Prove that C is the midpoint of x. My drawing's not. Oh, anyways, they're the same length. For this problem, one obvious thing that we can do is let's just say that this is O, like the center, like the circumcenter of AFP to be O. So if OC is 90 degrees, then we finish our proof. So how should we prove that OC is perpendicular to XY? And actually here I spent like hours trying to utilize like quadrilaterals, like cyclic quadrilaterals AFXPY. I also even tried to use like Pascal's hexagon theorem to somehow Pascal's theorem to somehow use the collinearity of 3 points to like do something. But then I realized that that's not like that helpful. The only thing helpful here is angle tracing. Okay, so because we reflected H, should we call this point, should we call this angle alpha? Let me use red color. This is alpha, then this should obviously be alpha. Then we know that because this is alpha, this angle is also alpha. And that is because, let's call this beta. Then this is also beta, and this is obviously alpha. Is there a better way to connect them? No, I'll just write them like beta, beta. So I think I can just use these colors. Wait, maybe I can use visual proof. I found them very elegant, so I want to use them one day. Well, I think I might be able to use it here, which is great. Is there any reason why I put dot here? No, that was a mistake, right? Yes, I hope so. If this is alpha, this is beta. So alpha plus beta is 90 degrees, so this should be beta, because it's 90 degrees here, and alpha plus beta is 90 degrees, so this should be alpha. Okay, then let's connect our line like this. So F to O. And the reason why we did this is because consider the chord FP. By this, we know that this angle, this angle right here, so FOP is 2 alpha. Therefore, FOCP is cyclic. Yes, we know that it is cyclic. What should we do from here? It is cyclic. How do you prove that? How do you prove that this angle, so OCF is equal to beta? So if this is beta, oops. This is beta, and this is beta. We just need to prove that OCY is beta. And how should we do it? Okay, first of all, because this is cyclic, we know that this angle and this angle is the same. So OCY is equal to OPF. So we just need to prove that this angle right here is beta. Is there an easy way to do that? OCF and this angle. So wait. Because I think I found it. Because it's been a while since I solved this problem. So OF and OP are equal to each other. Why am I Therefore, if we prove that OFP is beta, then we complete our proof. So how do you find OFP? This angle. Oh, I did it. So it's actually quite simple. This angle is beta. That's because we have 2 alpha here, and because this is a reflection, let me use different colors. These 2 angles, they're the same. That means triangle FOP and HCP are similar by are they similar? Yes, by SAS similarity. That's why this is beta, this is beta, this is beta. Therefore, we proved that this is 90 degrees. And And because OX and OY are equal to each other, OC and OC are equal to each other, this is right angle, so by RH, is it RAS or RSA? I don't really. RH. By RHS similarity, congruency, we know that C is the midpoint of XY. So that completes our proof. So, I love this visual proof. So this is problem. I think the kick for this problem is, so I remember spending lots of time solving this problem because I did like really meaningless stuff. So I defined this to be alpha, this to be beta, and this to be like gamma kind of stuff like that. So I think our first kick for this problem is to realize what is the significant angle. And in this case, alpha is not a bad choice because we know that we reflected this, so we could get more information out of it by using the reflection. And also, the right angle suggests that we could also find another angle, beta, and relate them to each other. So I think that's why we could say that alpha here is a meaningful alpha. And after finding the meaningful alpha, I think everything else is quite straightforward. So yes, I think like finding what is meaningful is the main point for this problem. So thank you so much for watching this video. I hope you enjoyed it, and I will see you tomorrow with very fun problem. Thank you and see you tomorrow. Bye.